So we're given an equation of an ellipse and we're given a point, and our goal is to find a point on this ellipse that's the furthest away from the given point. The first thing we're going to do is, because this is a calc 1 class, you're probably only comfortable with doing derivatives with just one variable. So we're going to solve for y in terms of x so we can do the rest of the problem only in terms of x. So we're going to subtract 4x squared on both sides. That'll give us y squared is equal to 4 minus 4x squared. Next up, we're going to take the square root on both sides. And that's going to leave us with y is equal to plus or minus the square root of 4 minus 4x squared. Now to solve this problem, we're going to need to remember a formula that you probably learned back in geometry or algebra 1. It's the distance formula, which is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. And we're going to use x1, we're going to let that equal to x. We're going to let y1 be equal to plus or minus the square root of 4 minus 4x squared. We're going to let x2 be equal to 1, and we're going to let y2 be equal to 0. So what these values, our equation should look like this. So this equation takes a point from our ellipse and tries to find the distance from that point to the given point. So this is the equation we're going to take the derivative of, find the critical point, and see whether it's a maximum or minimum. So we're going to simplify this equation a bit, and we're going to want to use this identity right here. A minus b squared is equal to a squared minus 2ab plus b squared. We're going to let a equal x and b equal 1. So that will let us simplify our distance formula a bit. X squared minus 2x plus 1. The other thing we're going to want to remember is that plus or minus the square root of any number squared is just going to be the positive version of that number. So then we will get plus 4 minus 4x squared. And then if we just group the terms together, we can simplify this to negative 3x squared minus 2x plus 5. Next up, we're going to want to take the derivative of our distance function. And that's going to be a bit tricky because it's a square root inside a polynomial, but we can use our definition of chain rule. And we know that the derivative of f of g of x is equal to f prime of g of x times g prime of x. So we're going to let g equal our polynomial and f equal our square root, and we're going to see if we can take the derivative of this function. So we're going to rewrite this as an exponent just to make the derivative a lot more easier to take. Here's the power 1/2. And then we just need to do power rule to get this derivative, so we're going to pull down the 1/2. And when we pull it down, we're going to have to subtract 1 here, so that's going to become negative 1/2. And we also still have to take the derivative of our polynomial, which is negative 3x squared minus 2x plus 5. And that is going to be equal to 1 over 2 negative 3x squared minus 2x plus 5 raised to the power 1/2. All I did was use properties of exponents to pull this part underneath the denominator. And then the derivative of this is just going to be power rule once again. There's a negative 3x squared, so that's going to turn into negative 6x. And then the negative 2x just loses its x buddy when we take the derivative of it, so it just goes to negative 2. So I've gone ahead and set our derivative equals 0. So now all we want to do is we're going to want to solve for x. So I'm going to multiply both sides by 2 times negative 3x squared minus 2x plus 5. And I want to do this on both sides of the equation because that's going to get rid of this fraction. And when we multiply the square root on our left hand, the 0 times the square root will just make it 0 still. So that will leave us with 0 is equal to negative 6x minus 2, which then we can infer that 6x is equal to negative 2, so x must be equal to negative 1/3. Just brown arrow. So when x equals negative 1/3, the natural question comes, what does y equal? We have our equation from earlier, y squared is equal to 4 minus 4x squared. So when x equals 1/3, this equation becomes y squared is equal to 4 minus 4 times negative 1/3 squared. And then simplifying this out a bit, we get y squared is equal to, so I'm going to first work on this negative 1/3 squared times 4. That is going to be equal to, well, negative 1/3 squared is 1 over 9, right? So we're going to have 4 over 9. And when you're when you're subtracting fractions, you're going to want them to have the same denominator. So we're going to have to rewrite 4 in a way that will subtract easily with 4 over 9. And we can do that by just multiplying by 9 over 9. So 4 times 9 is 36. And 1 times 9 is 9. And here, I'll even write that out just to make it easy. Or just to make it easier to see what I was trying to do there. And that's going to be equal to 32 over 9. So now we know that y squared is equal to 32 over 9. So that means that y is equal to plus or minus the square root of 32 over 9. And we can do a little more simplification here. We know the property of algebra, which says that the square root of AB is equal to root A times root B. And we also know that 32 is equal to 16 times 2. So continuing our simplification, we get y is equal to plus or minus the square root of 16 over 9 times root 2. So that means y is equal to plus or minus 4 over 9 root 2. And then that's going to be our x and y pair. We actually have two solutions here. We have negative 1/3 comma 4 over 9 root 2. And we also have negative 1/3 negative 4 over 9 root 2. Now there's one more thing we need to do. We need to find out if our given pair is a maximum or a minimum. So we found the critical point of the distance equation, but the problem is we don't know if the points given to us were a max or a min. I've written out this small little fact here that whether we chose the positive or negative y values, the distances between that point on our ellipse and the point 1, 0 are going to be the same. I've also noted that both these distances are greater than 0. So all we have to do now is we just have to find another random point on our ellipse and see whether that point has a smaller distance or greater distance than the point that we found. This is actually really easy because the point 1, 0 is actually on our ellipse. So if we try to find the distance of the point 1, 0 and the point 1, 0, that's just going to equal the square root of 1 minus 1 squared plus 0 minus 0 squared, which is just equal to 0. Thus, the point we were given is a maximum. So thank you for watching. I hope you enjoyed the video.